All right, so today we're going to start looking at something called polyatomic ions. So up on the screen there, we see something that looks, thank you, something that looks very familiar, Mg. We know this is on the periodic table. That is just straight up magnesium. And if I look, it has 2 outer shell electrons. 2 is closer to 0 than 8, so it gets rid of those 2 electrons. It gets to 0. It now has 2 more positive protons than negative electrons. So magnesium forms a charge of positive 2. This right here is nitrogen with 3 oxygens. This is an ion. This is a polyatomic ion. Well, not yet. I have to give it a charge. When it's a polyatomic ion, it's going to form a charge of -1. And we're going to get into why it has a charge of -1, what this thing looks like when we start talking about covalent bonding. For now, we just need to know this right here, this NO3, this acts like one thing with a charge of -1. So one thing I might actually do with this is I'm going to put this thing in parentheses. I'm going to put the -1 out here because I can't change what NO3 is. This will always have to have 1 nitrogen and 3 oxygens. Okay, this whole unit together is -1. I can change how many NO3s I have, but I can't change these subscripted numbers in here. So if I put these parentheses, that means I know I can't change anything inside of it. If I want to know what this compound looks like, if these two things undergo an ionic bond, I already have the charges written up there. Now I just need to crisscross them. That 2 is going to go outside the parentheses. That 1's just going to go right by the magnesium. So when this forms an ionic compound, I end up with Mg parenthesis NO3 2. All right, this way I know I have 2 units of NO3. You won't ever have to memorize that NO3 has a charge of -1. You have a shortcut, you have a handout that tells you that NO3 has a charge of -1. Right? And so to figure out its chemical formula, you write the charges, you crisscross them. Pretty basic. But now we need to name this thing. So remember with names, we always start with naming the metal. So in this case, Mg, that's magnesium. All right, so now I need to name this part here. I still don't care that there's 2 of these NO3s, all right? I just need to name what the negative ion is. Even if it's a polyatomic ion, I just need to name it. So in this case, you're going to check your sheet for NO3, and you're going to find that that's called nitrate. That's it. When it comes to naming polyatomic ions, you name the metal, or you name the positive ion, and you name the negative ion. There are some positive polyatomic ions. Ammonium, NH4, has a positive 1 charge. I don't need to change this name or anything like that. If we only change it to IDE, if it's just ending with a simple element like oxygen, chlorine, something like that. That's really the gist of all this. There's nothing too complicated. It's actually a little bit easier naming wise than compared to the ionic compounds we've been working with. I would say the only thing that makes it slightly difficult is the fact that you have to now look up what the charges are on these polyatomic ions and then what their names are. Like, that's it. Other than that, good luck.